Here is a good image that is going to summarize all the steps that are going to lead to ejaculation. Now, as you can see in the first step, we're going to have the pudendal nerve stimulate the sacral plexus, which is the region that is found between L4 and S4. Once the pudendal nerve stimulates this region, the pelvic nerve is going to carry its parasympathetic stimulation to the corpus cavernosum. Now here is corpus cavernosum. It is the erectile tissue that is found in the penis, and what you want to know is that the pelvic nerve is ultimately going to lead to an increase in nitric oxide levels through its parasympathetic stimulation. Now in the corpus cavernosum, which is found over here again, we're going to have these smooth muscle cells within that tissue, and these smooth muscle cells are going to have an enzyme within its membrane, and this enzyme is guanyl cyclase. What guanyl cyclase does is it is going to convert GDP into cyclic GMP. Alright, and what we need to know is that nitric oxide is going to increase guanyl cyclase levels. This is going to result in an increase in the conversion of GDP to cGMP. Once we have high levels of cGMP, high levels of cGMP are going to lead to vasodilation. Vasodilation is going to lead to an increase in blood flow, and this increase in blood flow is going to cause erection. One clinically important thing that we need to know is that the enzyme phosphodiesterase is going to break down cGMP. Why is this important? Because we could actually target phosphodiesterase so that we can have high levels of cGMP so that we can achieve erection. So this is actually used to treat erectile dysfunction. Viagra is the most commonly prescribed medication to treat erectile dysfunction, and the way Viagra works is by inhibiting phosphodiesterase. It is a phosphodiesterase inhibitor. If we inhibit phosphodiesterase, we don't have the breakdown of cGMP, so we're going to have high levels of cGMP, which is going to ultimately lead to erection. Now, we've talked about erection. Now let's talk about the third step in our image, which is emission. Let's erase all of this stuff so that we can focus on emission. Emission refers to the finding of semen in the prostatic urethra. So here's the prostatic urethra. Once the semen reaches the prostatic urethra, it is going to be referred to as emission. How it is going to achieve this is through its sympathetic innervation by the hypogastric nerve. Now, the way we switch from the parasympathetic innervation through the pelvic nerve into the sympathetic innervation by the hypogastric nerve is through the cerebral cortex. With enough parasympathetic stimulation, the cerebral cortex is going to go, okay, this person has had enough fun for the day. It is going to reach the threshold, and from the parasympathetic stimulation is going to switch to sympathetic innervation with the hypogastric nerve. Now, the hypogastric nerve is found in the spinal cord levels T10 to L2, and as we mentioned previously, it results in emission of the semen to the prostatic urethra. How it achieves this is by contracting the different structures. So it is going to contract the epididymis, it is going to contract the vas deferens, it is going to contract the seminal vesicle, and it is also going to contract the internal urethral sphincter that is found in the bladder. So once the internal urethral sphincter is contracted, it is going to close it off so that the semen does not backflow into the bladder. And all this is going to result in the finding of the semen in the prostatic urethra. Now, finally, we're going to have the step number 4, which is ejaculation, and this is also going to be done by the pudendal nerve. So the pudendal nerve is going to start this whole process, and it is also going to end it. And the way the pudendal nerve achieves ejaculation is through contracting the ischiocarinosus muscle and the bulbospongiosus muscle. Once these muscles are contracted, we're going to have the semen flow out from the penis, and this is referred to as ejaculation.